Hello everybody, and welcome to the troubleshooting tutorial. So in this tutorial we're going to go over two separate problems that you might encounter with your KeebCard. This is a prototype, it's purple, that's the only thing that's different though, so it should be exactly the same. And with this prototype right now I have the pause cycling going on, you can see right there. So very frustrating, but that one is actually one of the easier ones. The other problem that I've seen pretty frequently is, plugging in and nothing works. So we'll get to that in a minute, but I have this one set up to diagnose the pause cycling, so we'll do that first. So, let's see. I have notes this time. I came prepared. We actually know a lot of things because it's pause cycling. Obviously, it's getting to the program. The microcontroller is programmed correctly. Odds are you didn't burn out anything while soldering. There are traces, that go from the pins to different parts of the board that run the board. The traces for PB0, PB2, ground, and VCC are all in working condition. And then what we are pretty damn sure of is that the trace for PB4 is for some reason going low. So going low means that it's showing a low voltage, low enough that the microcontroller thinks like that's a zero. You're closing the switch. I'm gonna pause for you now. Cherry MX and kill switches are normally open switches, meaning that when you press them, they make an electrical connection and allow the current to pass through them. Our switches are connected from a pin to ground, meaning that when we close the switch, the current on the pin goes low. In order to make this work, we use what's called a pullup resistor. That is, it's hard to see, but those three resistors down there, R1, R2, and R3. And what a pullup resistor does is it's just like a tiny way for voltage to escape to the pin from VCC. So the effect of that is when you let up the switch and there's no longer an electrical connection to ground, the pin will relatively quickly travel back up to VCC, and that should be a high state. So I like to employ a Sherlock Holmes method of solving issues, which is you start with the most obvious solution and just keep ruling out the most obvious solution until you find something that actually works. So first and foremost, issue number 0 would be if you did not correctly install those pull-up resistors. You should probably do so. I know I said in the other video that all of the 0805 components you could probably get away with not soldering. That's still true, but the problem is that if you don't have a pull-up resistor, the current is going to float on the pin. Attiny 85s do have internal pull-up resistors. They're very small, so we added some a little bit beefier ones, just for fun for the most part. And those are the external ones that you soldered. But if you can go into the code and you can actually enable those internal pull-up resistors, and that will probably work just fine as well. But you do have to modify the code. So I will give links to that down below in the description. Yeah, but if you have the resistors, you should definitely use them. So the next most common problem would be solder bridge to ground. So solder bridges are when solder spans multiple pins when they shouldn't be connected. And so the easiest place for that is actually on the microcontroller, which is probably what you all thought. So this one's relatively easy to see right there. I made this like a couple of minutes ago, but it is pretty easy to get a solder bridge pretty far into the microcontroller. So even if things look okay, I would still definitely check and make sure. So one of the easiest ways to check for a solder bridge is to use a multimeter. If you don't have a multimeter, I definitely recommend one. They're pretty cheap. The one that I use cost $20. I got it on Amazon. I'll put a link below. But you can probably get them for even cheaper if you want. But make sure, so we're going to be using the continuity tester. So make sure that you get one that has continuity testing. So what continuity testing is if there's a negligible amount of resistance between the two probes here. Nope, that's not the continuity. What? It's supposed to beep at me. Ah, there we go. Okay. Alright, it just didn't like how fast I turned that dial there. Okay. Alright, we're soldiering on. We're doing it. So, the way this is supposed to work, right, there are lots of components in between all these switches, so even though they're really close together, there actually should be a relatively high amount of resistance between them. I can test this here, right? I can test the top two right pins, right? I can press the probes down on these two pins and they don't beep. But what I'm going to notice now, and that should be true for, I think, every pin, every two sets of pins on the microcontroller should not have any sort of continuity. And so you can go ahead and test all that stuff. But the top second from the left pin is the pin that controls the middle button, and the top left pin is ground. So that is an extremely likely candidate for where the bridge is going to be. And so if we do that, if we touch those two pins, yep, there you go. We get a beep. So the beep means that there's continuity, which means that electricity will very easily flow from whatever point you put one probe to whatever point you put the other probe. If you don't get a beep there, let's see. If they don't beep, you have some more sleuthing to do. The only thing that I could think of besides like an internally bridged trace is if the battery is really dead, or some sort of parasitic something is causing the voltage to drop incredibly low on that line. So you can do a quick check for that by checking the voltage drop across the pins. It should be higher than like 1 something. So, though I don't think the exact value matters. So I believe we can do that really quick. And I think you do have to plug this in. Let's see. So we would want ground. Yeah, let's, yeah, no, we don't want millivolts, okay. Yeah, you do want to plug this in, so, plug this in. Oh wow, this one, oh there you go, okay, this one's Tetris. It takes a little while. So you should see, the voltage drop across these damn pins. There you go. Took me long enough, but that was 3 volts. You can just barely see over there. It's pretty finicky. Give me a sec. Let's see if I can't hold this a little better. There. So, ground. 3 volts. There you go. Okay. So yeah, you should see 3 volts across, across that pin to ground, the top second to left pin. If you don't see that, if you see something lower than that, that is your problem, but I'm not really sure what it is. I would check the voltage of the battery really quickly. If the battery is super dead, it might, I don't know. I'm not even sure if you can get the battery down that low and still have the screen on. But, you know, it's worth checking. So, so we have diagnosed basically that there is a solder bridge between PB4 and ground. So the next thing that we can do is we can get rid of that solder bridge. So I'm going to use my soldering iron. I'm going to tin the tip a little bit. I have a fume extractor over here on the left. And so what I like to use for desoldering, you can use whatever you want, right? But I have this, it's getting old. This is Engineer SS02 solder sucker. And so the nice thing about this one is it's got the silicone tip that I really probably have to replace. It's a consumable tip, but I haven't found anything that gets better suction than this. And then it's also one of the ones that has like a recoil compensation, so it doesn't. With a lot of the cheap ones, they will just, you know, they'll shoot back and then it slams into the board. But to be honest, if you didn't want to get this one, it's like $25, I think. It's a little expensive. If you didn't want to get one of these, I would just go for one of the cheap ones, because generally they have a much stiffer spring, and they do actually, before they smash into the board, they actually suck pretty well. But it's difficult to keep them in the correct place and, you know, not like smash things off the board. So I went with this one. So hopefully I don't mangle this, and I need to pull over the arm again. This could lay a little flatter. So heat it up. Oh, actually, yeah, there you go. That's it. I didn't even need to. I might go over it later though, but yeah. A good way to not get solder bridges in the first place is to use some kind of flux. I like the pens, but to be honest, I haven't really tried the solid flux. It scares me a little bit. It's not good for you, but it definitely works really well. And so all you would do is, while you are assembling the board, probably a little late, but I don't know, I guess it's worth it anyways. While you're assembling the board, you would just spread the flux over the pins, or over the pads, before you soldered anything. And then the flux will bubble, and it will clean the joint, and it will hopefully wick the solder where it is supposed to go. And to be honest, if you don't have a solder sucker, you could add a little bit of flux to your pins and then just run your soldering iron across it, and that might get the flux to go where it needs to go anyways. But yeah, so let's check this, make sure it works. Hey, look at that. You got it. Oh gosh. I flipped the directions on this, and now I'm a much worse player than I used to be. Cool. So we talked about number 2. Let's go to number 1. So the other thing to talk about is if the screen doesn't work at all. If it doesn't turn on, there's no program. Unfortunately, this can be for a ton of reasons. Something is structurally wrong with the PCB, like a broken trace. It could definitely be a solder bridge again, or a solder joint that wasn't properly soldered. It could be that the screen or the microcontroller is burned out. There might be bridging across the back pull-up resistors. Maybe one of the pull-up resistors was burnt out. The microcontroller maybe wasn't flashed, or was flashed incorrectly. If that's the case, my bad, I'm sorry. The battery could be really dead, or the battery holder could be soldered in backwards. So a couple of these things are easy to check. If you have a programmer, the first thing I would do is see if you can flash a program onto the KeebCard. If you can successfully flash a program, it almost has to be the screen, since it means almost all of the traces are good, because we use 6 of the 8 pins in order to program the microcontroller. And it also means that the microcontroller itself isn't burned out. I would double check the solder joints on the screen, and if they look good, I would check to make sure that the back pull-up resistors are on properly, aren't burned out. There are no solder bridges. Um, and so, as a last-ditch effort, I'm not sure if this will actually fix anything, but you can desolder those resistors. And it's these two right here on the back that I'm talking about, because you don't need them. You might not need them. I have soldered a bunch without those back resistors, and they do fine. They're in the specification for the communication protocol, but it is just like one less variable that you have to worry about. So you might as well. And then if that doesn't work, you can, I don't know, leave a comment here, and maybe we can get to the bottom of it. So if you can't program it, then we can go back to that list of things that it could possibly be. Some of these things can be used via visual inspection. So I would look at all of the solder joints that you made. I would make sure that they all look good. I would make sure that the pin is making contact to the pad, and I don't know that there are no bridges or anything like that. I would double check all of the traces that you can see and make sure none of them are cut and there aren't any burn marks on any of them. And what else? Let me see. Yeah, so as far as components burning out, usually they emit a puff of smoke when that happens, but you can also usually visually tell. The casing will be bubbled or deformed. So if any of the pieces have a bubbled or deformed case, I would take that component off, get a replacement if you can. But like I've said before, most of the really tiny stuff you could probably do without. Just, you can do without, not, you can burn it out and just leave it on the board. So yeah, if that all looks good, I would double check the battery. So let me see if I can get this. Yeah, so this is the correct orientation of the battery. I'm just rotating it 180 degrees. So you can see that the plus sign is facing the plus sign over here. It is a little confusing in the beginning. What else? What else is confusing? Another thing that's confusing is the battery goes in this way, and so I guess you could rotate the plus to be near the other plus, but the plus is facing upwards, and that's working correctly. Yeah, I forget why this was confusing. It looks a little weird when you first plug it in. And then if that's not it, I would check the voltage on the battery. And so that is the same as checking the voltage off of the pins, but you're just going to be doing it onto the battery. So we switch to DC volts. Plus is this side, so that's red, and then ground. And look at that, we got 3.11. That's a pretty good battery right there. So if you've done that, I would check the solder joints one last time. I've never had anything that wasn't just some improperly soldered component. And then if the solder joints are still good, you can hit me up in the comments and maybe we can get to the bottom of it. So yeah, that's all I've got for you folks. If you have some other problem that you haven't seen, that you didn't see get troubleshooted just now, or I don't know if you have any tips that you found while you were doing your own troubleshooting, please, leave a comment below. Yeah, have a good one.